Okay, welcome back. Next up is Colin Mollenauer from Texas, if I know. Is that right? Are you from Texas? Have I got it right? Sorry? Tennessee. Oh, I'm sorry. Tennessee. I got that wrong. Too bad. My bad. Anyway, Colin is quite well known in Magento developers because he has a couple of widely used projects on GitHub, mainly Modman, short bash script that's also used by Angry Birds deployment pipeline, and some people have used his MongoDB resource adapter models or MageLite, basically using Magento as a general purpose framework. So he's doing a lot of things, and he's been one of the most, I always found he produces very high quality code, and I learned a lot from him. So recently, he's been working on cache backends for Magento, and there were a couple of very interesting discussions going on along those lines. So I'm very happy to have you here. Thanks for coming, and welcome.
Thank you. Thanks.
Oh,
yeah, I don't need that.
Oh, I didn't get that. Sorry.
Thank you. Again, my name is Colin Mollenauer, and I'm here with Business Services and Solutions. I've been working personally with Magento just since early 2009, and we're a small team based in Knoxville, and we basically just service a small number of clients that we have an interest in, so we're not an active company in the public eye. So you probably haven't heard of us. We have a highly distributed team of coders all over the world. That's kind of what has fueled some of the projects that I've been that I've released, like Modman, just different deployment tools, things like that. We integrate with a lot of third-party solutions providers, such as Webgistics is here, and they do our third-party order fulfillment. We just done a bunch of a wide slew of Magento-related things in the mostly internal, but some of it I've been able to put out in the open source and let everybody take advantage of them. And we're hiring, so if anyone's from Tennessee or nearby or is interested in moving to Tennessee, talk to us later and we'll see what we can do. So I'm going to be talking about the Magento cache, and I guess I should clarify, since there's so many different levels of caching, you have caching on reverse proxies like Nginx or Akamai, things like that, and you've also got Magento's full page cache, and I'm going to be talking about Magento's core cache. So that's the system that caches things like Magento's config.xml when it's merged with the core config data, block outputs that are cached, all the Zen components. You might have not realized that a lot of those use caching for things like locale information. They use all the dates, and those Zen classes use the cache backend as well. You might or might not be caching remote API data, expensive database queries, things like that. So out of the box, Magento uses the cache heavily, and then if you've done a lot of customizations, you probably have added some additional resources that are cached. So cache system is pretty simple, keys and values, but then when you add tagging to it, it's a little bit more complicated. If you want to be able to clear a cache key for some reason, you need to be able to clear just that key, or just keys and related keys. And if you have to clear the entire cache, then that kind of causes a problem for your store performance. Or if you're clearing cache too often, any kind of hiccups can cause your store to fail miserably. So tagging lets any kind of event that occurs that clears a cache tag, such as saving a product in the back end. If you've noticed that's really slow, it's possible that your cache backend is struggling to keep up. And when customers place an order online, some cache tags are cleared. There's all kinds of different events that cause cache tagging to come into play. So the Zen cache system uses a cache front end and a cache back end. So it's kind of abstracted, and it's nice that you can just drop in any one of several back ends and hopefully improve your performance. So that's pretty much what I'm going to be talking about for most of the rest of this presentation is a comparison of all the cache backends and which ones you'd want to use in certain situations and which ones you want to stay away from. So out of the box, these are the ones that you can enable in Magento without any additional code installation. You get the files backend, which is the one that's enabled by default. Database, which uses the MySQL database. Memcached. APC, Xcache, and eAccelerator are all really fast caches that are built into the web server process. Whether that's Apache or FPM, they're running in that process. Then you got the Zen server cache backends, SQLite, and then there's a TwoLevels cache backend, which lets you combine two of those, and we'll go over that in a couple minutes. And then there's some alternative cache backends, and basically these are the ones that I've written. So you got the Redis backend. How many? Raise your hand if you've heard of Redis before. Okay, so it's pretty popular product. It's a great open source database that we'll talk about more. There's an index files backend that I'll be introducing as well, and a simplified TwoLevels backend. So Magento's got a little bit special needs when it comes to caching. Tags are used, as I've said, really heavily, and so your backend has to support tags, and it has to perform well with tags. If you're using more than one web node, it needs to be cluster friendly. It's really ideal to have one cache. It's probably possible to have each web node have its own cache, but then they wouldn't be notified of tag clearing and things like that. So you really need one cache backend shared by all your web nodes. And then you want your cache backend to be high concurrency, so that kind of rules out SQLite. And you want your cache backend to be persistent. This might not be as important to everyone, but if it is persistent, it's a good feature because if your web server gets restarted or whatever, or just crashes in the middle of a peak, you don't really want it to start up with a cold cache. So if it's persistent, then you can sustain reboots without losing your cache. So the TwoLevels backend basically provides one backend for the front end, and then it uses two separate backends as an abstraction. So they call it the fast and the slow backend, and that doesn't really necessarily mean that one of them is fast, one of them is slow. It just means the fast one supports or does not support tagging, and the slow one does support tagging. So those backends that I said didn't support tagging, like APC and Memcache, stuff like that, those can be used as the front end or the fast backend, and then you can use a slow backend to support tagging. So a couple problems with the TwoLevels backend is one thing, it's just redundant. You're caching data in two places as opposed to one, and so all those operations occur on both backends. And then it's got some bugs that some people in the community have pointed out. It's got a couple synchronization issues. It has a priorities feature, which doesn't work too great. And so basically, I took that backend and just stripped out a bunch of code and made it so that the slow backend would just strictly store tags, and the fast backend would strictly store data. And just simplifies things a lot, and we'll see how it performs in a minute. So Redis, you guys, a lot of you are familiar with it. It's basically an advanced key value data store, so it's kind of like Memcache in that it stores keys and values, and you can look them up really quickly, and it's in memory. But it has a bunch of additional features like sets, sorted sets, lists, hashes. These data structures can be used to enable you to do things that you couldn't possibly do with Memcached or other key value data stores that don't have those features. And it's persistent to disk, unlike Memcached. So it runs in memory, and then it has a background process that persists it to disk, so that it'll sustain a reboot without completely wiping all your data. It has an automatic key expiration feature, so that if you set a key to expire in 60 minutes, it'll be deleted without any additional work on your end. You can specify maximum memory, so if you're running on the same server as something else, it won't bug in your code or something unexpected wouldn't cause your cache backend to consume all of your server's memory. And it supports master-slave replication, a bunch of great features. So the backend that I wrote that uses it tries to be as simple as possible for loading a cache key. It's just a single call. For saving a cache key, looks like 3 calls plus 1 call for each tag. So if you have 10 tags, it would be 13 calls, but they're very, very fast. Cleaning cache is one operation like a union or a intersect, or basically a set operation to get the IDs that match a cache tag, and then just deletes them all. And then removing cache is also 2 operations plus 1 for each tag. And then the file backend that we'll be seeing also, this was inspired by Vinay's Symlink backend, which basically the Zend backend doesn't do any indexing of your tags. So to find all the tags or all the IDs that match a tag, it has to iterate through each key. So if you get up to 10,000 cache keys, that's 10,000 files that it has to read, open, and aggregate. So if you're using the file backend and you notice that product saves are slow, this is basically why. So basically what I do is for each tag, it keeps a file, just a simple text file. Each line in the file is a cache ID. So whenever you're writing a cache key, it'll just append that ID to each tag file that ID is supposed to be tagged with. It randomly compacts the tag files if they get too large so that repeated saves wouldn't cause it to grow. It uses file locking to make sure that 2 concurrent operations can't corrupt any tag data. Also fixes a bug with the Zend cache backend distribution that uses just a poor hashing algorithm that with Magento's prefixes cause all the hashed file names to also have a similar prefix. So it didn't really distribute well. Basically, Linux or whatever file systems don't support a huge number of files in the same directory without degraded performance. So fixed a bug with that. And about to show you a bunch of benchmarks, but before I do, I'd like to just show my testing methodology so that you understand exactly how I'm coming up with these numbers. So basically, I generate test data one time, and then repeat that test using each backend. And so the data is the exact same data used for each backend, and the tags and the operations that are performed are all repeated identically for each test. You can set the number of tags per key. You can set the number of the data size for all your cache tags, and it's all randomized. But then it's randomized, but it's stored so that you can reuse it. So basically, it loads all the cache data into a clean environment. Using Bash, it just forks a separate PHP process for however many you chose to run it with. They all perform all their operations, and then it sums the result. So it's really a stress test. It's not as much a real-world test. You can customize the parameters to be like your real-world experience, but then it's really just a stress test because it doesn't do any additional, it doesn't do any database queries or other Magento code. It's just strictly cache calls. So in choosing the parameters for these tests, I just took our live store and ran this analyze command. So you can basically just download the code, install it, and then just run that command, analyze. And it'll just count all your keys, tell you your data size distribution. So you can see here, the median is 32 kilobytes. A lot of really small keys, and then there's a few keys that go up to close to a megabyte. It's probably the Magento cache because that gets, the Magento config because that gets pretty big. And then also the tags per key, it looks like 9 is the median. I just chose 10 in my test. You can see down at the bottom here, That's the command that I use to generate the test data. And then to run the actual test, you just, that one line right there, and it'll run the test for you. So it's very easy to run the test, and I encourage you, if you're working on improving your cache backend, to download this and run it. And I think I've got a link somewhere for you. Now, look on my GitHub account, github.com/ColinMollenauer, if you want to get the code for this. So you can see the keys per tag. I chose, well, I just basically tuned the minimum and the maximum, and then it randomizes everything. And so now we're ready to get on to the actual benchmarks, the fun part. And so for this test, I just had a pretty moderate machine. It's a dual quad-core Xeon. I think it's got 12 megs of L3 cache, so 12 gigs of RAM, RAID hard drives. And I did all the tests on Magento CE 1.6. And then these are the backends that I tested. And I didn't test the APC and backends that exist only in the web servers, because the test runs the command line, and basically each process would have a separate cache, so it wouldn't actually be a real-world test to test like APC and the accelerator and those cache backends. And besides, if you're doing a clustered environment, you can't use those anyway. So, so here's the first basic comparison, and we've got basically reads, writes, and cleans are benchmarked separately for each backend. You can see the files backend is a good performer, but then the cleans are non-existent. So, in real-world cases, this can actually take like 20 seconds to perform one clean. So that's something you probably run into before as your store's grown, saving products and checking out, things like that clear cache tags cause poor performance. So we'll get on to this is just a basic comparison. So this is 4 concurrent clients. So that means basically if you have your web server's running 16 users per second, I mean, each of those processes isn't going to be pounding the cache. It's going to be doing other things as well. So 4 concurrent clients is really quite a bit with the cache backend. But we'll see how these all scale with concurrency in just a second. So you get the reads on the left there, and then the writes in the middle, and the cleans on the right. And this is basically scaled from 2 clients to 64 in increments of, 2, 4, 6, 8, 2, 4, 8, 12, et cetera. Number of concurrent clients. So 64 concurrent clients would be, a huge store. But you can see the behavior. What you want is your cache backend to have consistent performance as the number of clients increases. You don't want it to start degrading. So you can see the files backend, does great on the reads, okay on the writes, really well. And then down here you can see it's pretty much poor across the board. The database backend doesn't have great read performance, but it's at least consistent. So that's MySQL does great scaling as far as concurrency, but it's not necessarily the best cache backend. To note here, I guess you can see the Redis backend. It gets up to about 30,000 request operations per second, which is, like I said, a lot. I'd guess, depends on your store, but a single page load might hit the cache, up to 100 times maybe. So just divide or multiply your, Apache requests or whatever by that to kind of get an idea of what your store would need to scale up to. And let's see, you can see Memcache does real well here. It continues to scale up as you increase the number of clients, and all the writing and the cleaning as well. The files back in, you can see they're kind of erratic with their performance, and that's probably just due to operating system, inode caches, all kinds of complex stuff that I don't really care to dig into, but they're a little bit less stable, as you can see. And then I also did some capacity scaling tests. So, when you start out and you have 500 products, you're not going to have a whole lot of cache keys. But if you have 1 million products, there's a couple cache blocks per page. You might have hundreds of thousands of keys. So, did some tests to see how the backends perform as you increase the number of keys, and that's where the files backend, it does great at first, but it pretty much starts to degrade after 10 or 20,000 keys. So you can see a lot of the other backends do real well if they're not the file system based. And that's what you're looking for, is basically a straight line. You don't want it to degrade performance as you increase the number of keys. So I think the ugly cache backends here are the file backend and the not so much, but also the database backend. Files backend is just doesn't use any kind of indexing, so it's really not an option once you get above a certain number of keys. And TempFS is what some people recommend to use, but did some tests with it, and it's the operating system caches real well, so it's not even going to improve read performance at all. Only impact write performance, not really even clean performance, because it's still the same file system design. So in the database backend, in my opinion, you don't really want your cache backend to be on your database, because the whole point is somewhat to offload that work from your database. So, but it's not an entirely bad thing. If you just use it as a slow backend for your tags, then it's not doing so much work. So it's still a viable option there. The Redis backend is very resource friendly. Like when I deployed it in our store, I couldn't even notice CPU usage increase. And then of course we got a lot of a reduction in I/O use because of got off of the files backend. It's very consistent with its concurrency and capacity scalability. Has very low latency, which basically will help your page render time. It's not faster latency than the files backend, but it doesn't degrade, so that's a good thing. And one thing I will mention is that it's single-threaded, which means at any given time, the Redis backend cannot use any more than one CPU core. So that's basically where it kind of starts to hit a ceiling. If you have a 16-core system and just put Redis on there, you're only going to be using one core. So if you're using one Redis process, which is what I did in these tests. So if you want to use the Redis backend, here's some tips for you. I would use the max memory option. It basically limits Redis to use however much memory you want it to. As I said earlier, this is good so that it doesn't run off and consume all your server's memory. Definitely recommend using the volatile LRU policy. So Redis has a nice feature where you can choose what it should do if it runs out of memory. And with this policy, it'll delete or evict the least recently used keys. It's not perfectly least recently used. It just picks random, like 3 keys randomly, and whichever the least of those, least recently used of those is what it'll delete. And the tags keys in Redis are not volatile, so that way when your server runs out of, or when the Redis process hits its max memory limit, it won't delete your tags information. So that's why I recommend using that one. You can use compression. So it'll use either gzip, LZF, or Snappy. This will basically just let you store more stuff in the same amount of memory. And it's pretty fast to decompress and compress. So I would actually, you might think it's kind of too much work for it to decompress it, but it actually, it'll help you scale more if you want it to. So if you just want the best performance and you're really low scale, then you could turn compression off and it might be better. But for high scaling, it helps Redis spend less time storing information. And then there's a native extension that gives you native PHP performance when it's communicating with the Redis server, and that'll help a little bit with the latency. So I did some compression tests just to validate my thoughts on this, and there's not a whole lot of variance, but you will notice that compressing does give you a net increase in scalability. So you get more out of your Redis server when you're sending it compressed data, but of course your web nodes will have to work a little bit harder to decompress. So it's a trade-off. And then the new file backend is great for single machines. If you're on a single machine and under 50,000 keys, it's a great backend to use. But of course, if you're going on to 2 machines, then it's not an option. And the final backends to discuss are the Memcache backends, along with the other TwoLevels combinations. So using Memcached plus Redis, you might think doesn't make sense. Why not just use Redis? But Memcached is multi-threaded. So if you have a 16-core machine, you can configure Memcache to use all 16 cores. So you could really serve a lot of cache requests with Memcache plus Redis. So I'd use Redis for the tagging and Memcache for the data. And then you can also just use Memcache plus database, which is probably what a lot of you are using, because that's the best option other than Redis for a clustered environment. So again, there's MySQL is a transactional database, and you don't really need transactional features to store cache records. So it's a little bit overkill for a simple feature, and also it'll contend with your other MySQL queries. So in general, my recommendations are, if you're on a single web node, either use the file, the new indexed file backend, or the Redis backend. And if you're on a medium deployment, I recommend using Redis because it'll scale up quite a bit. And then if you're on a really, really large deployment and Redis isn't quite serving everything you need to, you could do Memcache plus Redis. So that's basically the conclusion of the cache backends. There are a couple other possibilities I just thought I should mention for completeness. MongoDB is a database that's becoming increasingly popular, and it actually models cache data very well. It's blazing fast, but haven't tested it in real world environment. There's someone else wrote a backend for it that you can check out. And one thing about Mongo is it doesn't have any kind of online compaction. So if all these records being deleted and added and deleted and added cause fragmentation, and there's no automated way of handling that. So you might have to do some fancy stuff to combat fragmentation. So I'm not recommending it just because I haven't tested it, but it's something to look into if you need even more performance. And the other option would be to use sharding with Redis. Use one shard for the tags and other shards for the data, and use like a consistent hashing method. In theory, that would be a great way to scale as well. And let's see, I got some. Let's see, got a couple more minutes, so I'll just real quickly. A similar problem to caching is also session handlers. By default, the Magento uses PHP's file session handler, but if you go to a cluster environment and you don't have a load balancer that handles sticky sessions, then you want your session handler to be cluster friendly. And even if you do have a session handler that has sticky sessions, it's still nice to have a central storage for that in case one of your web nodes goes down. You don't lose a fraction of your sessions, because losing sessions probably results in lost sales, or at least frustrated customers. So the files backend is the default one. It's great for single servers. I wouldn't really recommend changing it. The MySQL database would be a good one, but it actually doesn't lock sessions. So if you have two requests going at once, one request, when it completes, if they complete out of order, could overwrite the other request's session update. So it's safest to have a locking mechanism. It's not an absolute requirement, but I wouldn't recommend using a database one just because it doesn't have locking. The Memcache one would be good, except for it's not persistent, and you don't want to reboot to lose all your sessions. I mean, big stores could have 100,000 users or 20,000 users online all at once, and you don't want to lose all those sessions in a case of a power switch getting flipped or something. So it's really best to keep a persistent session storage, so I wouldn't recommend Memcached. And eAccelerator, and there's a backend for that as well, but it's kind of all of the above, not good for those reasons. So I wrote a Redis backend for sessions, and it has the same features that make it good for a cache backend as well as a session backend. It's persistent, it's network, or it's a central storage, so it's cluster friendly. It expires keys automatically, so there's no garbage collection needed. And using the Redis features, I implemented some optimistic locking so that your sessions are locked for safe updates. And this also includes a migration script, so you can, if you're on the file backend, it'll read in all your sessions and transfer them over to Redis, so you can transfer all your customers over with 1 or 2 seconds of downtime. So that's online right there if you want to check it out. It's all of it's on GitHub, but you can also use these links here. So the optimistic locking, it's pretty simple. You increment a lock key and a hash, and then if it's 1, you have the lock. If it's not, you don't have the lock, and you keep trying every second until you do have the lock. So this is kind of an edge case. Most cases, there won't be a lot of contention on a single session. But if there is, it's locked using this method. After 120 seconds, it'll try to break the timeout, and after 180 seconds, it'll just fail, and then but your page will still render, you just won't be able to write that session. So that's basically how the file locking works already, or the Memcache backend. So it's nothing too different, but it does work. So that's all I have to say on the cache backends and the session handlers, and I'll answer any questions now.